Hello everyone, welcome back to my YouTube channel. I am Pallavi. I am studying in Sri Venkateswara College of Engineering in second year, third semester from ECE department. Today's subject is network analysis. In that, I am going to explain about classification of electrical networks. Let's see first electrical network. Classification of electrical networks. Electrical networks come in a variety of classification based on their components, configuration, and behavior. Understanding these classification is crucial for effective design, analysis, and troubleshooting of electrical system. Firstly, let us learn about introduction to electrical networks. Introduction to electrical networks. First one is passive components. Passive components means resistors, capacitors, and inductors. These are the passive components. These passive components, they do not need any external power. These are the passive components. And second one is active components. Active components are voltage sources, current sources, and semiconductor these devices. These are the active components. These components that require external power. These are the active components. The difference between passive component and active component is passive component they do not need any external power, and the active components they need some external power. This is the difference between passive component and active components. Third one is network configuration. Network configuration is nothing but arrangement of the component. Arrangement component means um, like series parallel and series parallel. These are the arrangement of the components is called as network configuration. Now let us learn about the difference between passive and active components. Passive components and active components. Passive components are resistors, capacitor, and inductor. Active components are voltage sources, current sources, and semiconductor devices. Passive components they do not require any external power to function. Active components they need external power to function. Passive components store, dissipate, or transfer energy without additional energy input. Active components generate, control, or amplify electrical signals and energy. These are the difference between passive components and active components. In resistive networks, let us learn about Ohm's law, series resistors, parallel resistors. Firstly, known about the Ohm's law. We are using Ohm's law in so many theorems in network analysis. It's an important and required formula for all network analysis problems and all. Ohm's law is nothing but describe the relationship between voltage, current, and resistance in a circuit. The Ohm's law formula is V equals to I into R or I equals to V by R. It is a basic formula of Ohm's law. Series resistor, total resistance is the sum of individual resistor value. Is called as a series resistor. Parallel resistor, total resistance is a reciprocal of the sum of the reciprocal of the individual resistor values. It is a parallel resistors. We can identify the resistor value by using color coding. Brown black brown is a 100 ohm, brown black red is a 1 kilo ohm, brown black orange is a 10 kilo ohm. um, in capacitive networks, we can see capacitance, series capacitors, parallel capacitors. Capacitance means the ability of components to store electrical charge is called as capacitance. Series capacitors, total capacitance is the reciprocal of the sum of the reciprocal of individual capacitor values. Parallel capacitor, total capacitance is the sum of the individual capacitor values is called as a parallel capacitors. In inductive networks, we can learn about inductance, transformers, series inductors. Inductance means the ability of components to store energy in the form of magnetic field is called as a inductance. Transformers means device that use electromagnetic induction to transform energy between the circuit is called as a transformers. Series inductors, total inductance is the sum of the individual inductors values is called as a series inductors. Let's see series and parallel configuration. Series configuration, components are connected end-to-end connection, sharing the same current, is called as series configuration. Parallel configuration, components are connected to the same set of the terminals, sharing the same voltage is called as a parallel configuration. Let's see difference between balanced and unbalanced networks. First, balanced networks, all components have equal impedance. In unbalanced networks, all components have unequal impedance. Balanced networks, they are arranged symmetrically. Unbalanced networks, they are arranged asymmetrically. Balanced networks provide consistent performance and are less susceptible to interference. Unbalanced networks may experience voltage drops, current imbalance, and increases susceptibility to interference. These are the difference between balanced and unbalanced networks. Here some network theorems and analysis techniques. These are the most important theorems or techniques in a network analysis. And these are the most important theorems. First one is Kirchhoff law. It is the most important and required law to solve all problems in a network analysis. Kirchhoff law is nothing but describe the relationship between voltage, current, and power in a network. Is called as Kirchhoff law. There are two types of Kirchhoff law. Kirchhoff law. One is KVL and second one is KCL. KVL is nothing but Kirchhoff voltage law. KCL is nothing but Kirchhoff current law. This is about Kirchhoff law. And second one is superposition theorem. Superposition theorem allows the analysis of a network with multiple sources by considering them one at a time. Is called as a superposition theorem. Thevenin and Norton equivalent circuit is nothing but simplify the complex network into a equivalent circuit with a single voltage source and the resistor. It is called as Thevenin and Norton equivalent. These three are the most important and required theorems or techniques in a network analysis. Here some applications and real world example for electrical networks. First one is power supplies. Electrical networks are used in power supply circuits to convert the regulate voltage. It's one of the example for the network electrical networks. And second one is motor control. Electrical networks are used in motor control circuit to regulate speed and torque. Third one is home automation. Electrical networks are used in home automation systems and in monitor devices. These are the some basic examples of the network electrical networks. Thank you to all for watching my video. I hope this video is helpful for you people, and I hope all are understood all the concepts, and thank you to all once again.